Hello PLP Geometry. Welcome to the last video of Unit 7 and the last video of your geometry course this year. We are finishing up our probability with a discussion on what's called conditional probability. So again, this is Unit 7. Again, the last video of Unit 7. So remember, we started off with 3D geometry, finding all of those volumes, and now we're finishing with probability. And again, this is our sixth lesson in the unit, sixth and final lesson on what's called conditional probability. Now, you discussed this a little bit in Algebra 1, but again, this is a little bit more advanced discussion. So let's define conditional probability. So conditional probability. Okay, so conditional probability is defined as the probability, so probability, that event B will occur, that event B, that's a B, I'll make it better. The probability that event B will occur given, and I'm going to like given that event A already occurred. And I'll underline that. Okay, so it's the probability of a second event happening given that the first event already happened, right? So notation-wise, so the probability of B given that A occurred, so that bar means the word given, is equal to, so it's a fraction. So on the top, it's the probability of the and. So it's the probability that A and B happened, A and B occurred, all over the probability of A happening. This is your formula. They do not give this to you on the state test, so you need to remember it. Okay. What I always say about conditional probability is instead of looking at the grand total, you only look at a subset of the group. So again, you only look at the A's of the group because we know that A happened. So it's just those people, that event. Okay. All right, so I have an example to go over with you on conditional probability. Okay, so this is example 1. So of course we have a table here. So I'm going to make the table with you first. Okay. All right. So this is about grades and gender. All right. So I need this and this. Okay. So it's about having an A or not having an A. So A or no A. And then we have females here and we have males there. Okay. So it says there are 6 females with an A, 13 males with an A, 5 females without an A, 3 males without an A. Okay, and the question is, and I'm going to give some space here because we're going to put some totals here in a second. So what is probability that female students, what is the probability that, and I'm just trying to, yeah, that a female student, that female student does not have an A? Okay, so when we take a look at this problem, right, it's sometimes hard to interpret it as conditional probability, but this word that is very important. What is the probability that a female student, we know that this student is female, right? We know that female is happening. That is our condition. That is who we're just looking at. So again, when we do look at the table, we're not going to look at everybody. We're just going to look at the females. So that's important, right? And the question is, what is the probability that a female student does not have an A? So no A, right? That's the other part. Okay. So when I look at this table, first thing is let's fill out the totals, right? So let's put a T here and a T there for total. Let's add down. So we get 11, we get 16. Let's add across. We get 19 and we get 8. And either add down or add across, you get 27. Okay. Now again, we're not going to look at that 27, right? We are focused on just the female column only. So we want to find the probability that this person does not have an A. So no A. Again, I don't know why I closed that. No A. Given, so bar, given that they are female. Okay? Well, that is going to be the probability of being a female and having no A over the probability of being a female. Now, when we do these out of two-way tables, we're not really looking at the probability. We're just putting the numbers, right, the frequencies. So how many total females are there? So there are 11 total females. Of those 11 females, how many have no A's? That's this 5. And there's your fraction, 5 out of 11. If they want a decimal, just divide them. If they want a simplified fraction, that is simplified, and you're done. So there's a, 5 out of the 11 females do not have an A. Okay. All right. The second talk of this lesson, okay, is going to be about test for independence. We talked about independence in the last video. So independent events have no effect on each other, right? The probability of one does not impact the probability of the other one. Independence. So we have a test for independence that we can do using conditional probability. So test for independence. If events A and B, if events A and B are independent, then, and here's our rule, then the probability of B given A will be the same as just the probability of B, and the probability of A given B will be the same as the probability of A. So again, what this is saying is that on the left case, right here, right over here, I'm looking for the probability of B. What it is saying is that it doesn't matter if we know that A happened or not, the probability of B stays the same. So again, what this is saying is it does not matter, does not matter that first event occurred. Right? That's what this is saying here. It does not matter that the first event occurred. Okay, so let's take a look at a problem here to discuss this. Okay, so this is example 2. Okay, so it says determine whether eating breakfast and passing the test are independent. Round 2 nearest thousandth. Determine whether eating breakfast and passing the test are independent round to the nearest thousandth. So here's my two-way table. You're going to get data. Okay. Again, they don't give us the totals. So this is breakfast, no breakfast, pass, fail. And our numbers are 1, 41, 4, 8, and 86. Okay, so what we want to do is we want to determine whether eating breakfast and passing the test are independent. Now, they are going to give you a suggestion on what to do. So in this problem, they suggested, can you see if the probability of failing, given that you eat no breakfast, is it the same as the probability of just failing, right? If these are the same, what that means is that eating breakfast is independent of failing. All right. Okay, so let's take a look here, right? So to find the I'm going to change colors. To find this conditional probability of failing, given that I eat no breakfast, I need to find the number of people who ate no breakfast and failed over all those who ate no breakfast. Okay? Well, no breakfast and failed. Let's do this first. Let's find the totals. So we're going to add down. So that's 149. We'll add down. That's 90. I'll add across. That's 145. I'll add across. That's 94. And then we'll add down or add across to get 239. So there's a total of 239. So for this first conditional, we're not going to use the grand total. We're just looking at the no breakfast row. So in this row, there were 94 people who didn't eat breakfast, and out of those 94, 86 failed. We would divide that, you get 0.9148. So we round that to 0.915. Okay, so you had a 91.5% chance of failing if you didn't eat breakfast. Okay. So now let's do the probability of failing. Well, the probability of failing is just all those who failed out of the grand total. So there were 90 total people that failed. That's this row, or I'm sorry, this column. 90 total people that failed out of the grand total of 239. So I'll circle those numbers. 90 out of 239. You divide those, you get 0.365. So that rounds to 0.377. So obviously those are not equal. So because they're not equal, that means that they are not independent, which means that they are going to be dependent. So now if we take a look here, you can see that if you did not eat breakfast, you have a higher chance of failing than just, anybody. So higher chance of failing if you didn't eat breakfast. So that's what this means. I'm going to write that down right here. You have a higher chance of failing. Higher chance of failing if you didn't eat breakfast. Okay, and there you go. So again, those probabilities being different leads you to this dependent case of one affecting the other. All right, great. There is a small mini lesson, and then there's a practice online. All right, best of luck. We'll see ya. Congratulations, you made it.